So consider this given problem statement. So it says that if A, B, C belongs to the set of positive real numbers, so this R plus denotes the set of positive real numbers, such that this given constant, that is A is strictly greater than 10 and B and C is greater than or equal to 10, right? And this is the given equation that we are having. So in that case, we need to compute the greatest possible integer value of A, right? So let us try to solve this step by step. Now, first of all, let me just put this equation as it is, and then we'll be using the logarithmic properties, right? Now, using the properties of log, I'll try to resolve this particular equation. Now, if you observe this one, so before I resolve this further, I would like to remind this property that when we have log of argument m and the base is n, so we can take some intermediate base such that the log remains defined, that is log base a. So we can introduce this intermediate base as per our requirement, log base a, and argument is m, and this can be written as log base a argument n. Now based on this, I'm going to split this part, right? So if you observe this numerator, so this numerator can be written as, this numerator can be written as, so I will be writing here as natural log of a plus b divided by natural log of 8. So this particular expression I have written for the numerator, right? Now similarly, if I apply the property for this, so this would be log, let's say natural log of c divided by natural log of 2. On taking the reciprocal of this one, this turns out to be natural log of 2 divided by natural log of c. In the similar way, I can expand this part as well, right? So this is written as log of argument a minus b. So this a minus b can be written here as it is, and this would be natural log of 27. In the similar way, this denominator, that is log c base 3, this would be log natural log of 3, and this will be natural log of c, right? And this is equal to 2 by 3. This is equal to 2 by 3. Now we have used this property, so I'm going to remove this part. Now, on proceeding to the next step, proceeding towards the next step. So I will rearrange the terms here. I'll rearrange the terms. So this log, natural log of a plus b, I'll write it over here. And this natural log of 2, I'll write it over here. Similarly, this natural log of a minus b, this one I'll write it here. And log of natural log of 3, I'll be writing it here. Now, on moving to the further step, so if you observe this one, that is natural log. So this can be reformed as, this can be reformatted as log base 2, sorry, log of argument 2 and base 8, and 8 can be written as 2 to the power 3. So whenever we in base we are having 2 power 3, so that turns out to be 1 by 3. Now on resolving this, we'll get 1 by 3. So on resolving, log 2, that is natural log of 2, and in the denominator natural log of 8, so this can be combined as log of argument 2 base 8, and that resolves to 1 by 3. And same holds for this log 3, natural log of 3 divided by natural log of 27. Now this one can be written as log of base c. We are combining this actually, right? And in the argument we'll write here a plus b. Now similarly, this natural log of 3 divided by log of natural log of 27. This can be written as 1/3 again, and this can be written as natural log of c, and this will be a minus b, and that is equal to 2 by 3. This is equal to 2 by 3. Now if you observe here, this 1/3 can be cancelled out, right? So this 3 in the denominator, this can be taken common and can be cancelled out, right? So from this we can write that natural log of argument a plus b to the base c plus log of base c and argument a minus b, this would be equal to 2, because this 1/3 is taken as common factor and cancel out, right? Now again, using the property of log, we can say that log base c, this will be multiplied, right? Whenever base is same and addition is there, this can be multiplied, that is a plus b times a minus b, and we very well know that it is equal to a square minus b square, and this is equal to 2. Now on proceeding further, so this a square, now I'll convert this logarithmic format into exponential form, that is a square minus b square, this is equal to c square. Now going ahead with the constraint of the question, it says that a must be integer. It says that a must be integer, so a must be integer. So in that case, the greatest possible value, the greatest possible value for a would be, of a would be, this will depend on this constant, that is a square. What is the max value that b and c can take? The maximum value that b and c can take is, that is 10. So according to this particular equation, so this can be written as a square can be written as b square plus c square. So that means that a square will be less than equal to 10 square plus 10 square. Sorry, in this case, yes, 10 square plus 10 square, that is 200. So a square must be less than equal to 200. And from this, it is clearly visible that if I take 14 square, that is 196. And if I go for 15 square, that is 225. So in that case, 14 is the maximum value that we can take. So in that case, we can say the maximum value of this a that can be taken is 14. So for this problem statement, 14 is the answer. So in this entire problem statement, one property was very important, that is, if I have log of a to the base b, then we can take some intermediate base. That is, to frame it again, I would say, if I have log of m to the base n, that can be written as log of base a m, argument m, divided by log of n, and in the base we'll have the whatever is the desired base, we can take that there, right? So using this property, I resolved it till this much. Now addition to product property I have used over here, and I applied the constant, and hence I got the answer as 14 as the maximum value. So this gives the answer for this particular problem statement.